Our research really revolves around understanding the structure and the chemistry of materials from the smallest length scales to the largest length scales. And we use a technique called electron microscopy that allows us to literally see atoms so that we can understand structure and chemistry at that atomic length scale, and using other microscopy techniques up to larger length scales. And the point is to be able to measure chemistry and structure and relate it to the physical properties of the material. Because ultimately the structure and chemistry dictates the properties, and it also dictates how long the material can last in service and how the material may degrade and ultimately break down. So one main class of materials that we work on are called electronic ceramics, and you may think of ceramics being what we make coffee cups out of and plates and dishes, which is true, but there's also some very technical ceramics that are used in computers, communication devices, and energy storage devices. And the properties and functionality of those materials are linked to atomic structure and microstructure. And so that's the relationship that we try to understand. We also are very concerned about how those materials and their properties change over time. So when you have materials in devices that are seeing electrical voltages and maybe they're at higher temperatures because maybe they're used in an automotive application, things change, things move around, and ultimately that affects the properties and can lead to the degradation and failure of the device. Our research really tries to understand fundamentals of how chemistry relates to properties and how we might, in the manufacturing of material, change its chemistry by small additions of certain elements or changing processing parameters that change the microstructure in a way that helps you optimize properties. We also try to understand the mechanisms, really at a very fundamental level, of what changes the material and leads to device degradation and failure. And so by revealing those underlying mechanisms, again, that provides a really good foundational knowledge on how you would design the material to mitigate those degradation processes. What motivates me, and I think everybody in my research group, is the ability to connect things at the very smallest length scales where we're seeing atoms and understanding how their arrangement and assembly ultimately impacts the properties of a device and a system that we use in our everyday life.